Hello, welcome back to this channel. In today's tutorial, we are looking at computer applications for mathematics education. Now, we are going to consider two of the commonest applications that we use for mathematics education, and one of them is Microsoft Mathematics. After this, we consider how to use GeoGebra to perform construction and transformation. Now, let's do a little exploration of some of the features of Microsoft Mathematics. So when you look at a Microsoft Mathematics, we have the calculator seat here, which of course where the pointer is showing. And with the calculator seat, we have sections. So for the first section, we have calculus, and under the calculus sections, we have commands here. We have the derivative of a function. We have the second derivative of a function. We have indefinite integral. We have definite integral. We have limits, summation, products, and infinity. Now, we also have a statistics section which we can explore random, standard deviation, geometric mean, combination, permutation, median, mode, mean, and the rest. We also have the trigonometry section where we can find sine, cos, tan, sine inverse, cos inverse, tan inverse, and the rest. Now, when we scroll down, we also have linear algebra section where we can find insert matrix, transpose, reduce, determinants, inverse, cross products, and inner products. And we also have standard sections too, where we can find factor, LCM, GCF, slope, round, expand. We can also find exponents or caret symbol, which we use for exponents. We also have square roots and then infoods. And then we have fractions too, which of course we make use of it in our discussion for today. Now, under the working area of Microsoft Mathematics, we have the worksheet area and then we have the graphing area. So for worksheet area, we use it to type normal equations, integration, or any function and just want to display the result. But for the graphing area, we use it whenever we want to display a graph of the equation or any function that we type in. Now, let's take this question. For the first question, we are to evaluate the limits u as it approaches 1. And then the function is 4u exponent 4 plus 5 on u squared minus 2 times 2u squared minus 1. So where can we find the limits? Now let's scroll up to calculus. We have limits. So we click on limits. But the limit is of u. So u approaches 1. So 1, and then the function is in a fraction form. So we go to standard and select fraction. So with the numerator part, we have 4u squared, 4u exponent 4, sorry. So the exponents, how to type the exponents or how to type exponents using the computer keyboard is to press on shift and then caret, which is on top of 6, or you use the caret symbol in here. Okay, so when you click on it, then we type our 4 here plus 5 on brackets opened u squared minus 2 bracket close, another bracket opened 2u squared minus 1 bracket close. So after typing your function, then you click on enter and the result will be displayed here. So the output of our function is equal to -9. Suppose you made an error and you want to correct it in your function and you want to call the function back to this area, then you click on edit entry and the function will pop up again for you to make the correction that you intend to make. So that is it. Okay, the next one we want to consider is the problem 2. where we have a triple integral. Because we are using integration, or we make use of the integral symbols, we go to calculus again and select definite integrals, because these integrals involve the upper limits and lower limits. Therefore, we need to choose the definite integral symbol. So we click on, and they are three. So we click on another one, and then the last one. For the first integral, we have 3 as its upper limit, and then 0. And for the second integral, we have 2 and 1. And for the last integral, we have 1 and 0. Now the function is of x, y, and z. Okay, suppose you want to type a function which involves x, y, and z. Let's type this function in a fraction form. So let's say we have x squared minus y plus z cubed on 12. Then we press enter. So you see our result is displayed here, which is 67 on 48. In a decimal output, we have 1.395833. Now, coming back to our third question, we are to display graphically a 3D wireframe with projections, the following equations on one graph. So because we are going to make use of graph, then we need to select the graphing worksheet or the graphing area. Now we select 3D here, but we have only 2 equation area. Therefore, we need to add another one to make it 3. So we click on add, and now we have 3 equation area here. So the first equation, we have x squared plus y squared plus z squared equals 1. Then it hits on enter. The second equation, we have x squared we have in a fraction form x squared on 4 minus y squared on 9 plus z squared on 4 equals 0. Then we hit on enter. And for the third equation, we have it also in fraction form x squared on 4 plus y squared on 4 plus z squared on 9 equals 0. We hit on enter again. Then we have to display this in graph using 3D wireframe and with projections. So we click on graph, and our result is shown here. Now let me maximize it for us to have a clear view. Now we are to use proportional display. So we click on proportional display. We click on color surface or wireframe. So when we click on wireframe, this is how it looks like. Now let's try to rotate this one in anti-clockwise or counterclockwise. So clicking on the counterclockwise rotation, we have our work shown here. This is so amazing. Okay, yeah. So any changes that we make affects our 3D graph. Let's also check on clockwise rotation. So we have our clockwise rotation here. This is so amazing. Alright, so this is how we use the Microsoft Mathematics to display a graph. Alright. Okay, so under the second section of this tutorial, We want to use GeoGebra to perform geometric construction and transformation. So this is the interface of the GeoGebra application. Now, because we are going to construct or do perform geometric construction and we don't need the graphing area, we can click here and we click on show or hide the axis, and also click here to hide the so we have a plain area here. That is great. So we've hidden the axis and then that's of the grid lines. Now we want to construct a triangle ABC such that AB equals 8 centimeters. So we want to construct line segment AB. So we click on line, then you select segments with given length. Then you click on any area of your working sheet or working area. So let's say we click here. The length is 8 centimeters. So I click on 8. So I have my line segment as 8 centimeters. Okay, let me drag it through so we have a clearer view here. Okay, now let me make movement so we have a clearer view here. Okay, now I want my endpoints, which is the A and B, to come at the bottom. So I'll click on move and put the endpoint A here, and I'll also put this one here. Alright, this is the measurement, but it is in name form. So I want to change it to value. So I'll put my pointer here and right click and go to settings. Then under the settings I choose value. So you see that this one has changed to a value. I can also use show label and or hide the label and it will go up. Moreover, I can also write my measurements there. So if I want to write my measurements, then I'll go to this area, which is the slider, and select ABC, which is the text, and then I'll click on any area that I want to type. Then I want to put line AB there. So AB, so I'll write AB equals 8 centimeters. Then I'll click on OK. So I have my AB here 8 centimeters. I want to hide this value, so I'll click on show label and it will go. Okay. Now the second part of the question. Sorry. Let me put this one on move. The second part of the question says we are to construct an angle at A, so angle ABC 105 degrees. So I will select angle with given side. So I'll go here, I'll go to point, and then I'll go to angle and select angle with given side. Then where I'm to draw the angle, we are constructing the angle at A. But I will first of all click on B and end at A so that the angle will be positioned at A. So I'll click on B, then click on A. And the angle is 105. So I have to change this one to 105 degrees. And it's in the anti-clockwise direction. So click on OK. Now clearly you could see that there is a point here. Okay, and I want to join point A to this point. So I'll click on line. Then I'll select the endpoint that will join the line. So I'll click on A and then click on B. I don't want to show this label. So I'll right click and go to show label. I don't want to show this one too. That is great. The next one is to construct angle 30. So we are to construct angle 30 degrees at B. So the same approach, I'll go to angle with given side, then I'll click on A and end at B because I am constructing the angle at B. But first of all, I need to position my pointer at A before B. So I'll click on B, A first, then B. The angle is 30 degrees. So 30, then I'll choose clockwise direction. Then I'll click on OK. So this is the new angle for B. Then I want to join this point to B. So I'll select line and click on B and end it at A. I don't want to show this label, so I right click here and then I'll go to show no label. The same thing I do for this, and then so that is it for the first section. Okay, the next question says that we are to construct the locus A1 of points equidistant from A and B. This means that we are to construct a perpendicular bisector of line AB. So we click here, we click on line, then we select perpendicular bisector. So we choose perpendicular bisector here. So we are to construct a perpendicular bisector of A and B. So I'll position my point at A and then B. This is done. Okay. The next one is to construct perpendicular bisector of point B and C. So because I've already selected it, I'll go to B and C. Of course, you don't have our C here. Okay, so we need to position our C well. So we select point and then click at the intersection of the first line here and the second line here. So we have our C here. Then I'll select perpendicular bisector and we click on B and then C. We have our bisector here drawn, constructed very well. Now the next question says that we are to locate the point P, the point of intersection of A and B. So the first bisector is point A. So in this case, I'll right click here and change the name to A. So that is what we have here, and I'll click OK. So the first one is A. So we can select rename and make it at A and click on OK. So the first one was A, and the second one was B. So this one was B. I'll click on OK, and the first one was A. So I will select A and click on OK. The next question says locate P, the point of intersection of A and B. So this is the intersection of A and B, and therefore I will choose or select point, click on the intersection of A and B, and I'm to name the intersection as P. So I'll go to rename and type P there and click on OK. Now the next question says using PC as radius, draw a circle. So this is my P and this is my C. So I'll go here and select circle with center through a point. We also have circle with center and radius, but in this case, because I'm using P and C as my radius, then I have to choose circle with center through a point. So I'll click here, click on P, and then end it as C. So this is what we have here. Okay, the next question is to measure BC. So where is our B? So I'm sure the question was to be P and C, because if I'm to measure BC, that's already done here. But let's check something here. So I'm to measure BC. So I'll click on distance. So where can I find? Okay, so I have my distance here. I'll search where I can find distance. So I'll click on distance here. Then I'll click on B. Sorry. So I want to measure. So I'll click on distance. So I'll click on B and then C. So I have my distance of BC as 10.93. This is amazing. Now, after finishing with your work, you can export your work as an image. So you just click here, go to export as image, you click on it, then you can download or copy it to a clipboard. So when you download, a menu will pop up for you to save it. So let me save this one as Geo1. Then I'll click on save and the image will save on desktop. Now let me go to the next question, which I'm to use GeoGebra to perform transformation. So in this case, I have the last question here. We are to perform the following transformation in GeoGebra. Okay, so this is what we are going to do here. So I have my first point as B, point A, which is 2 2. So here I'll make use of the inputs. So with the question 5, I'll make use of the graphing area. So I have my question here, and I'm to perform the following transformation in GeoGebra using the following guidelines. So I'm to draw triangle ABC with vertices A 2 2, B 6 2, and C 8 6. Now I will make use of, you can plot the points directly on the graph, or you can choose to use the input here. So let's say I want to use the input. I'll type in A bracket open 2 comma 2, and this is shown here. And the second point, I click on plus. Point B, which I have 6 2 bracket close, and then the last one I have point C, which is 8 6. All right, so getting this one done, I want to join then the points to form a triangle. So I'll click on polygon, then I'll join the points together, join A to B, B to C, and C to A. That is great. I don't want to show these labels, so I'll right click and go to show label again, and all these labels will vanish. The next question says we are to draw the image of triangle ABC under an anti-clockwise rotation of 270 degrees about the origin. So in this case, we need to locate our origin here. So I'll select point, I'll click on the origin. Then I'll go to rotation. So I have my rotation. So I'll rotate about rotate around a point. So I'll click on rotate around a point. First of all, I'll click on the object. You see that the object is highlighted, and I'll click on the point. Then a menu will pop up for me to type the angle. So 270 degrees counterclockwise or anti-clockwise. Then I'll click on OK. Now I see my rotated objects over here. The next one is to draw the image of triangle ABC under a reflection in the line y equals negative x. So therefore, we need to draw line y equals negative x. And therefore, I'll make use of the input here. So I'll type y equals negative x, and that is shown here. Now I'm to reflect triangle ABC under the line y equals negative x. So I'll click on the object here. I'll click on the object here. Then okay, so I'll click on the object. I'll click on reflect about a line. Then I'll click on the object. I'll click on reflect about a line. Click on the object. Then I'll click on the line. I have my reflected object here. By this label is A2. So I'll go to rename and make this one as A2. I'll do the same thing for this. Rename it as B2. And do the same thing for this. And rename it as C2 as well. Okay. And the last question is we are to draw a triangle A3B3. It's supposed to be A3B3C3 of triangle ABC under a reduction about the point E is negative 64 using a scale of 0.5. So in this case, I need to locate point E, and therefore I will use the input. Point E is negative 64. So I will type negative 64. Now this is my point E. Okay. Now the next thing is to do is to select dilate. So dilate from a point. Then I'll click on the object first and click on the point E. Then I'll type my scale factor, which is 0.5, and click on OK. So I have dilated the object ABC. So this one is supposed to be C3. So let me go to rename. So this is supposed to be C3, D3, 12, and this one will be A3 as well. Okay, that is correctly done. Now I'm to find A1, A image, and A2 image. So A image, the first one over here, and A2. So the distance between. So I will select distance. Then I'll click on A image and then A2 image 2 as well. So I have my distance as 4 centimeters. So this is how we can use both Microsoft Mathematics and then GeoGebra to perform mathematical problems or calculations, or how we can also use computer applications for mathematics education. Thank you very much, and don't forget to subscribe to our channel.